Hey, welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I am going to teach you some algebra right now. This is lesson 1.2. Let's call it multi-step equations. Our previous lesson dealt with single-step equations. These equations require more than one step. You just can't use the single application of the addition property of equality or subtraction property of equality to isolate the variable. We need to go through multiple steps to isolate that variable. Okay, so let's look at our first example. I'm sorry, the core concept of this entire lesson is in order to solve multi-step equations, you need to simplify each side first, if necessary. Okay, that's the big thing, if necessary, and then treat it like try to treat it like a single-step equation, but you may need to do more than one step. Use those inverse operations. What are those inverse operations again? The addition property of equality, subtraction property of equality, multiplication and division property of equality to isolate the variable. Again, that is what we're trying to do in all equation solving. Let's look at our first. If you need to pause the video to get that down, do so. I'm going to move on, and you'll see the first example right here. Example 1, solving a two-step equation. Now, in this particular example, there is no simplification needed. I can't combine like terms. I can't use distributive property on either side. So I'm going to just move to the part where it says use the inverse operations to isolate the variable. So the first thing I want to do here, I've got the x, it's multiplied by 2.5, and the 13 is subtracted from that. I'm going to add 13 to both sides. And of course, if we were asked to justify our steps, this would be addition property of equality. I'm not going to do that through all these examples here. You know how to do that already. 13 and 2 is 15. And then dividing both sides now by 2.5. We saw this yesterday. Dividing by itself, by dividing any number by itself, results in a 1. So 1 times x is x. And 15 divided by 2.5 is 6. So x equals 6. And it says check your solution. I'm not going to expect you to necessarily show your work, but you should always check your work. Either go through the steps like I'm doing right now, or go ahead and just mentally look at it. There's really no reason. There's really no reason to turn in a wrong answer that you're not sure about, because you can always check to know if you're right or wrong. So all I did was plug the 6 back into the original equation, right? The original equation for x, and then I simplified both sides, and I get a true statement: 2 equals 2, which is true. And again, that true statement indicates that 2 equals 2, a true statement, indicates that the solution of 6 is correct. So you should always check your work, either formally like this, or just know that before you turn it in, you can always check it. You should know whether it's right or not. Example 2, combining like terms. What does that mean? Well, like terms, in case you've forgotten, are terms that have the same variable factor. So in this case, 9x and negative 6x are like terms because they have that same x in it. And just to be clear, you should know this, they should have to have the same exponent as well. So both of these have that unseen exponent of 1. So I can combine these by performing the operation on the coefficient, which is the numeric factor. So in this case, 9x minus 6x is 3x. 9 minus 6 is 3. So 9x minus 6x is 3x. And then the plus 15 just comes on down. Because really, what does 9 times x mean? That means I've got 9 x's. And 6x means I've got 6 x's. Well, if I had 9 x's and I took 6 x's away, I'd be left with 3x. So that's a real quick explanation of that. Okay, so I combine like terms, and I can't simplify any more again. I can't combine any more terms or distribute. There's no more math I can do at this point as written. I have to use the inverse operations now. Here's why I have to go backwards. Okay, so I'm going to subtract 15 from both sides because, again, I want to isolate the x. So I'm subtracting 15 from both sides. So negative 12 minus 15 would be a negative 27, equaling 3x. And dividing both sides by 3, oops, let me show my division here. Negative 27 divided by positive 3, negative 9. Okay. Now that's correct, but you should, again, you should do a sanity check and make sure, just right here, just look at it, negative 3 times negative 9, negative 27, negative 27 plus 15 is negative 12. So just double check to make sure that your answer is right. And example 3, using structure. Now there's a couple different ways to do this problem. So I'm going to do this problem twice. And it's kind of a good indicator how you understand what we're doing here in terms of what these symbols mean and what you can do with them. Now, the first way you're probably going to do this the most often is to use the distributive property first, because you see a number being multiplied by a quantity in parentheses. So 2 times 1 is 2, minus 2 times x, 2x, and then everything else just comes straight on down. The plus 3, the equal sign, and the negative 8. Okay, and now I can combine like terms. The 2 and the 3 are like terms because they have the same variable factor, which is they don't have one. So these are what we call constants. These plain numbers we call constants. Okay, so 2 plus 3 is 5, so negative 2x plus 5 equals negative 8. And now we want to move into the part of the solving where we use the inverse operations. So let's subtract 5 from both sides. And some people cross this out because that means it's a 0, right? Negative 5 plus 5 is 0. So I have negative 13. If I add this up, over here I have negative 2x, and just bring that down. And dividing both sides by negative 2, those cancel because negative 2 divided by negative 2 is positive 1. Positive 1 times x is x. And then a negative divided by a negative is a positive, so 13 halves. You can leave it as 13 halves. I like improper fractions. Different books are different. I think in our book they have it as 6.5, which is also true. But here's the second way you can look at this problem. You can treat it almost like you can treat the first steps here as if it is a two-step equation, but you're keeping that 1 minus x together as a single entity, a single value, let's say. Okay, so let's say instead of 1 minus x, just kind of imagine this was just like an x or a y by itself. Then what would you do? Well, I would subtract 3 from both sides first. That leaves me 2 times the quantity, 1 minus x. And that's how we say that. When I say the quantity, I'm referring to something in parentheses. I could say 2 times the difference, 1 minus x. But when I say it that way, I'm usually referring to something in parentheses. Okay, so negative 8 minus 3 would be negative 11. And now what can I do? I can divide both sides by 2. So I'll have 1 minus x equals negative 11 halves. And Typically, when I'm doing algebra, I like to leave it as improper fractions, because if you convert it to a mixed number, you can't really do math on it until you convert it back into an improper fraction. Okay, so I'm going to subtract 1 from both sides here, but since I have a denominator of 2, I'm going to think of this as subtracting 2 halves from both sides. Okay, so these will cancel, and that's going to leave me negative x equals negative 11 minus 2 is what? Negative 13. Negative 13 halves. And then think of negative x. Anytime you see a negative number, think of that as, how are we thinking of that? As negative 1 times x. Because this means the opposite of x, which means negative 1 times x. Anything that's a negative, or anything that has a negative sign, it really means the opposite. So this means the opposite of x, which means to multiply by negative 1. So how do I get rid of that negative sign? I divide by negative 1. And I do that on both sides. Okay, so that's going to leave me a positive x on this side equal to a positive 13 halves on this side. So I get the same answer. Okay, so it's a different way to do the same problem, but you're thinking of this quantity together. But all the other rules of math still apply. As long as you're following the rules of math, you can do things like this. Okay, just a different way of doing it. And that's it for now. We'll take a look at the we'll do some practice in class and take a look at the word problems, and there's a little bit more involved things in class that I like to do as a group. So have a good rest of your day, and I'll see you in class. Bye-bye.